Hello everyone, I am Prateek Kumar. In today's video, we will discuss about the application of circular motion using with the help of a solved problem. So as I mentioned in my previous video on the application of Newton's law, solving any problem in mechanics essentially involves following these four steps. So the first step is choosing the system and the frame of reference. Second step is drawing the coordinate axis. Third step is drawing the free body diagram. And fourth step is writing Newton's equation along the along the axis of the coordinate system. So let's apply these four steps in solving today's problem. So let's understand the problem first. So there is a table as shown in the by this red line. This table is kept on the ground, and on this table a pulley is fixed. A pulley is fixed. There is a string around the pulley. At one end of the string there is an object of mass small m. At the other end there is an object of mass 2m. This table along with this entire setup is rotating about a point C on the ground at an angular velocity of omega, right? This point C about which this entire setup is rotating is at a distance of small r from the pulley, from the center of the pulley. The problem is to find out the acceleration of this object of mass 2m with respect to the table. Now there are three assumptions in this problem. The first assumption is that every surface is frictionless. So between the ground and table there is no friction, between the tabletop and these objects there is no friction, between the string and the pulley there is no friction, right? Second assumption is that the string always remains tight, it never slacks. So essentially what it means is that these two objects will the magnitude of acceleration of these two objects will be same. The direction may be different, but the magnitude will remain same, because if the magnitude will be different, then the string will slack, right? The third assumption is that the distance of this pulley from the center, which is r, this r is much greater than the length of the string, right? So what it means is that for all practical purposes, we will consider that these objects are also at a distance of small r from the center. We will ignore the length of the string. Let's apply these four steps to solve the problem. First is choosing the system and the frame of reference. Well, since I have to find the acceleration of this object of mass 2m with respect to the table, so let me choose this table as my frame of reference, right? As far as system is concerned, so I will choose these two objects individually as the system. So first I will choose the small m as the system and then do the subsequent analysis on it. After that I will choose this 2m as the system and then do the subsequent analysis on it, right? Second step is drawing the coordinate axis. So by the geometry of this problem, I will choose the Cartesian coordinate system to solve this. So the x-axis will be along this direction, y-axis along this direction, and z-axis along this direction. So as you can see, this table is lying horizontally, so this table is lying in the xy plane, right? And the unit vectors along the x-axis, y-axis, and z-axis are I cap, j cap, and k cap respectively. Now let's draw the free body diagram for both these objects. So for the first object of mass small m, what are the forces acting on it? The first force which will act will be its weight, and it will be in the vertically downward direction as given by mg along minus k cap. The second force will be the normal reaction due to the table. It will be in the upward direction along k cap. Now what is the normal reaction? So as I mentioned in my previous video, that whenever two objects are in contact, then each object will exert a force on the other object, and the direction of the force will be perpendicular to the surface of contact, right? Now the third force will be the tension due to the string. Now just pay attention over here. Whenever in mechanics you get any problem involving strings and the string is taut, then the string will exert a force on the object to which it is attached, right? And the direction of the force will be away from the object, right? So because of that, we are having a tension T over acting on this object of mass small m. The fourth force which will act on the object, as you can see over here, is m omega square r I cap. So what is this force? So this force is essentially the pseudo force which is acting on this object of mass small m. Now why the pseudo force is acting? So since my frame of reference is this table, and this table is rotating about the center at a constant angular velocity omega. So as we saw in our last video, this table will accelerate, and the acceleration will be given by minus omega square r er cap plus dv by dt et cap. Now since the angular velocity is constant, so there will be no dv by dt component. And mind you that ER cap is the radial direction, ET cap is the tangential direction. So since omega is constant, so there will be no tangential component of acceleration. There will be only radial component. So along the radial direction, this table is accelerating towards the center C at an acceleration of omega square r as observed from the ground. So if we are observing from the table this object of mass small m, so this table becomes my non-inertial frame, so I'll have to apply a pseudo force on this object of mass small m. So the pseudo force direction will be opposite to the direction of acceleration of the table or the frame of reference. So the pseudo force will act in the outward direction along the positive radial direction or along I cap, and the magnitude of the force will be given by mass times the acceleration of the table, which is m omega square r I cap. Right, so this is the free body diagram of this object of mass small m. And on this object of mass 2m, again the forces will be similar to what we have seen. There will be its weight, which will be 2 mg along minus k cap, normal reaction n dash from the table along k cap, the tension T from the string. Now just note here that the tension which acts on this 2m is actually, we have taken same as what acts on m. Now why we have taken the tension same? Because the pulley around which the string is moving, this pulley is frictionless. So that's why the tension which acts on m is equal to the tension which acts on 2m. Now had there been friction involved, the tension would have been different. So just remember this this another rule with regards to string and pulley. And the fourth force is the pseudo force, which is 2m omega square r along I cap, along the. Now let's apply the fourth step, which is writing Newton's equation along the coordinate axis. Well, before that, just observe the motion of these objects carefully. So as we can see, both these objects are not moving along the z direction, along the vertical direction. They are only moving along the x direction. And since this object of mass 2m is heavier than this object of mass small m, so essentially this heavier object will pull this lighter object. So this 2m, this heavier object will accelerate along the positive x direction, and this lighter object will accelerate along the negative x direction, right? So now let's apply the fourth step, which is Newton's equation along the axis. So the equation states that summation of f. So I will write the equation along the x-axis. I will ignore the equation along the k-axis or z-axis, because along the z-axis both these objects are not moving. So anyway, these forces will cancel out. So along the x-axis for object of mass small m, the forces are T minus I cap plus m omega square r I cap is equal to ma minus I cap, because of the reason we discussed just now. For the heavier object of mass 2m, the forces are 2m omega square r I cap plus T minus I cap is equal to 2ma I cap. So this heavier object will move along the positive x direction. So if I remove these vectors, these unit vectors, I will get essentially these two equations. So there are two unknowns, t and a, two equations. I can solve them. If I solve them, I'll get a is equal to omega square r by 3. So acceleration of this heavier object with respect to the table will be omega square r by 3. The tension will be given by 4 by 3 m omega square r. So thank you. Thanks for watching. If you have found this video useful, then please subscribe to my channel.